Here we have another example. Look at this series. The series is n squared times e to the power negative n cube. The nth term here is n squared e to the power minus n cube. Therefore, let's consider the function x squared e negative x cube. This looks like a complicated function, so I'm going to use the integral test for this kind of function. For the integral test, I need to check three conditions. The function is continuous, positive, and decreasing. Okay, so let's check it one at a time. You guys notice that x squared is positive and exponential is always positive. Both numbers are positive for x more than or equal to 1. Therefore, this is going to be positive always. Why? Because x squared is positive and exponential numbers are always positive. Number one. Secondly, again, x squared is a continuous function, exponential is a continuous function 1 onwards. So because both functions are continuous, their product will also be continuous. Lastly, continuity is done. Lastly, to check decreasing, I'm going to try to find the derivative of the function. How do you find the derivative? This is product function, so we're going to apply product rule. Derivative of x squared is 2x, e negative x cube as is, plus x square as is, derivative of e's x derivative is same thing, times derivative of negative x cube is negative 3x square. I think I can factor out e from both of them and x. So x out, e out, 2 minus 3x cube. Now you guys notice x is positive because x is more than or equal to 1. This is positive. 2 minus 1. When we are more than 1, this number is going to be larger. So 2 minus 3 times something more than 1 has to be a negative number. So overall, f prime is negative. That means f is decreasing. So all three conditions are satisfied. That means the series, given series, behaves same as integral. So instead of series, we are going to just work on the integral. We've learned the integral technique, so that is easier to do. Let's look at how to, this is an improper integral example. So we need to write it as limit integral. Instead of 1 to infinity, we're going to write b approaches to infinity. X square e negative x cube. How are we going to do this integral? I think u sub will work. Let's write the integral here. Let's put u is equal to x cube. We can put negative x cube. Then du would be negative 3x square dx. You guys notice x square was already sitting there. That only gave me the clue. So du by negative 3 is equal to x square dx. That means my integral, in place of x square dx, we can write du by negative 1 by 3 and e the power u. Integral of e the power u is u the power u. And u putting back. Okay, this is the integral. So I'm going to put this back here. Limit b approaches to infinity. Integral is negative e the power negative x cube by 3 from 1 to infinity. How do we handle the definite integral limits? We put upper limit minus the lower limit, right? Limit b approaches to infinity. E the power negative b cube by 3 minus e the power negative 1 by 3. It's going to become positive because two negatives. Now, Look at this. B is approaching to negative infinity. This is e the power negative infinity. So this will become like 1 by e the power b cube, which will be like 1 by e the power infinity, which will be approaching to 0. So basically we are saying this whole thing will approach to 0. So our integral will approach to 1 by 3e. Okay. This is about the integral, but we had to know about our series. We have covered all the conditions of integral test. So series is gonna behave exactly similar. So series is gonna also converge to 1 by 3e because the integral is converging to 1 by 3e. Because of our integral test, all three conditions are satisfied, therefore series and integral are gonna behave similarly. The integral is converging to 1 by 3e, therefore the series is also gonna converge to 1 by 3e.